All right, we're going to be taking a look at solving systems using elimination. In order for terms to eliminate, they have to be exact opposites. So we are looking for the same number, so like a 2x and 2x. So they have to have the same number, but they have to have different signs. So one has to be positive, one has to be negative. It doesn't matter which one. Either way, as long as one of them is positive and one of them is negative, they will cancel out. They will eliminate each other to make 0. Again, if I have two that have the same sign, if I were to combine these, they would make negative 4x, and that does not cancel out to make 0. So if I have the same sign, what I need to do is I need to change one of the signs by multiplying a negative, or we would call that subtracting. So if I were to subtract 2x minus a negative 2x, this negative affects this negative to make this positive, because a minus means the opposite of. So the opposite of negative 2x is positive 2x, and that's where we do slash and dash. So now these could be combined. So we're going to do that on a whole like equation size scale. In number 1, again, the first thing we're looking for, will our x's or our y's have the potential to cancel out? And in number 1, our x's have the potential to cancel out because they have the same term, the same value, 2 and 2. The next thing we're looking for is, will they cancel out? And in this, they will cancel out because we have one that's negative and one that's positive. So when we have one that's negative and one that's positive, we are just going to combine our equations together vertically. And some students like to draw little like lines here. Because really what we're looking at is we're going to put these two together. So negative 2x and positive 2x is 0x. So that, I don't even have to write that down because it cancels out. And then positive y, negative 2y makes negative 1y equals negative 10 and positive 10. When I put those together, I get 0. So I get negative 1y equals 0. Now that I have one variable, I can divide negative 1 to both sides to solve, and I get y equals 0. Now that I know what y is, I'm going to plug it into either my top equation or my bottom equation. It doesn't matter which one. So I'm going to choose my bottom equation. So now we're going to do some substitution. I have 2x minus 2. And then instead of y, I'm replacing it with 0 equals 10. So I have 2x, negative 2 times 0 is 0. So I could say plus 0 equals 10, but 2x plus 0 is just 2x. And then I divide 2 from both sides, and I find that x equals 5. So we would write our answer as an ordered pair, x, comma, y. So again, when we're given two equations in standard form, I am looking for which ones have the potential to cancel out. I'm seeing, do I need to change them? If these don't need to change, then I'm just going to add my equations together how they are. If they have the same sign and they're not going to eliminate, then I need to subtract one equation from the other. So in this one, my positive 4y and negative 4y will cancel out. That will make 0y. Looking over at the front, we have 3x and 6x. If I were to combine those, I would get 9x. And this equals 18 plus 0, which is 18. So I really don't need this 0y, so I'm just going to rewrite 9x equals 18. And then we do a one-step equation to solve for x. X equals 2. So that's the first part. The second part is then we plug that into either equation, either the top or the bottom. So for this one, I'm going to choose the top equation. You can just pick whichever one looks easiest to you. I'm replacing x with a 2, so I'm saying 3 times 2 plus 4y equals 18. I use the whole original equation, even though I like cross stuff out or whatever. Now I work this out. 3 times 2 is 6, plus 4y equals 18. I subtract 6 from both sides, so that 4y equals 12. And then I divide 4 from both sides, and y equals 3. So I got my x value, comma, my y value. Okay, then the last two examples do not cancel out. So the first two, 1 and 2, we're adding our equations together. 3 and 4 are going to be subtracting our equations. What do we do when we have to subtract? So we've been doing work identifying adding or subtracting. Again, our y's have the potential to cancel out, but they won't cancel out how they are because they both have the same sign. So we have to subtract my whole second equation, this whole piece. We're going to subtract it from the first equation. And I'm going to write that over here. So this negative means the opposite of. So when we subtract, we're saying the opposite of a positive 5x is negative 5x. The opposite of a negative 2y is a positive 2y. And the opposite of 0 is still 0. We don't have to write negative 0. That's not really a thing. Okay, but if it were a number, we would take the opposite of that. My top equation stays the same, so I'm just going to rewrite it up here in black. It was a negative x minus 2y equals 12. Now I've created exact opposites that will eliminate. So I'm going to put my first two together, negative x and 5x, make negative 6x. Negative 2y and positive 2y cancel out. And 12 and 0 make 12. So now I have an equation that I can solve by dividing negative 6 to both sides to find that x equals negative 2. In order to now solve for y, we have to plug that in for x, and we can choose, I'm going to delete some things here so that we can see all of our equations. We can choose to replace this equation, or this equation. Well, I'm sorry, or this equation. Any equation. Any equation that we have as long as we use it. So I'm just going to pick this bottom one right here because it's the one that jumps out to me. So I'm going to rewrite 5, and then instead of x, I'm putting a negative 2 minus 2y equals 0. And then we're solving. 5 times negative 2 is negative 10. I add 10 to both sides first. And negative 2y equals 10. And then I divide negative 2 from both sides. And y equals negative 5. Now that I've found both of my answers, I'm going to write them as an ordered pair. So negative 2, comma, negative 5. All right, we're going to take a look at this one more time. My x's have the potential to cancel out, but they have the same sign. So I have to subtract my bottom equation from my top equation. I'll rewrite that over here. So when I subtract, it means I'm changing the sign of every term. So negative 8x is now a positive 8x. A positive 2y is now a negative 2y. And a negative 8 is now a positive 8. My top equation, I just rewrite how it was. So I have negative 8x minus 7y equals negative 8. I've created opposites that will eliminate. And now I'm just going to solve this. I'm going to combine these vertically. So I'm going negative 8x and positive 8x. Cancel out. Negative 7y and negative 2y make negative 9y. and negative 8 and positive 8 make 0. Now I can solve for y by dividing negative 9 to both sides, and y equals 0. I found what y is. Now I have to plug it in to find x. I can plug it into my top equation, to my bottom equation, to my equation that I changed. Doesn't matter as long as I write it down correctly and I plug the number in for the correct variable. So this one's for y. So I'm going to choose my bottom equation again, and I'm just going to write that down here. So I have negative 8x plus 2, and then instead of y this time, I'm replacing it with a 0, equals negative 8. And I'm working this out. 2 times 0 is 0, so I have negative 8x plus 0 equals negative 8. Well, plus 0 isn't really there, so I'm just going to rewrite this without the 0. I divide negative 8 to both sides, and I get x equals 1. So as an ordered pair, I would write it as my x value, comma, y value.